Hello, everyone. Mr. John here from Areteem Institute with this week's Thursday Tidbit talking about P and N positions for mathematical games. Now, this might seem like a random topic, but actually, this comes from a question from this year's AIME I. It was question number 3. So Alice and Bob play the following game. There's N tokens in front of them. They take turns with Alice going first, and every time they can either remove 1 token or 4 tokens from the stack. And you want to remove the last token, and then we want to count how many times there's a strategy for Bob to win. We'll come back to the actual question a little bit later. So we have this game, 2 people are playing it. There's not any special rules for either player. That's the other thing that's going to be important as we're talking about these P and N positions. Now, these get a little confusing to start, but let's go through the basics and start understanding what they mean. So a P position, this is a position where the previous person to move has a winning strategy. And an N position, this is a position where the next person to move has a winning strategy. We're talking about winning strategies because these things could work regardless of how the other person plays. So you have to have a strategy to combat whatever move the other person makes in that scenario. Now, just some very basic stuff. Why is this helpful? Why is this useful? Well, what happens at the start of the game? And this is kind of a little bit weird, but it makes sense once you kind of get used to this, and especially in our problem where we want to be considering a bunch of different starting positions as well. Well, if you start in an N position, right, then the first player wins. So the first player will win. And let me just say, wins here is a shorthand for the first player has a winning strategy, right? No matter what the person does, the first player can always combat it and wins. So as far as our question is concerned, this is Alice. So when we start thinking about these positions for our game, if it's an N position, that's a starting position where Alice can win. And N is next, right? So the game starts. Who's the next person to move? That's the first player. And we have to use our imagination a tiny bit, but a P position is the opposite. So the second player wins in that case. So this is kind of this scenario there. Again, if you think about our game from the AIME question in particular, think about there being more coins and then we just got to this place. Well, if we got there, right, then the second person just moved and that position would be winning for that person. So these positions will be winning positions for Bob as far as the game is concerned. Quick side note, why don't you just label this A and B positions or first player and second player positions? Well, the key with this is after a move is made, then the people swap, right? If Alice makes the first move, then that position they're currently in, now it's like Bob is the first player. And so things get a little confusing there. That's where this nomenclature of P and N positions, I've also seen this as winning and losing positions described there as well. Now, a little bit of a preview for the next slide. When we have a P position, this is a position where the previous person to move has a winning strategy. Let me put a little bit of a star by that because in fact, we're doing more here when we're talking about these positions. If I move, if I'm a player, I'm up, I make a move. When I'm done with my move, I am the previous person to move. Meaning, when we're talking about these P and N positions, it's also giving us a strategy. If it's my turn, I want to move to a P position. I want to move to a P position, then I just move. I'm the previous person to move. So if that's a winning position, I'm in good track there. And that brings us to some of our rules that really can totally determine everything here. So what happens from a position X? If we have a position on the board, what could we think of there? Well, keeping in mind what I just said, right? If you can move to a P position, right? It's my turn. I said I want to be in a P position after my turn. So if I can move to a P position, then it's currently, before I move, an N position. You want to be moving there. If it's my turn, I want to move to a P position. So then it's good if I can do so. So then it's an N position. The next player to move has a winning strategy by moving to that P position. However, if you're forced to move to an N position, that's not what you want to do. If it's my turn, I want to move to a P position. If I can't, then that's bad for me. Then it becomes this opposite. Then it becomes a P position. If it's my turn and I can't move to a P position, oh, the person who moved before me, i.e. the other player, has a winning strategy. That's bad for me. That is a P position. And you can use these strategies, you can use these things to come up with pretty much a full classification of these things. So let's start thinking about this in terms of our game here a bit. And I won't do a full proof of this, but the pattern is pretty easy, and as a challenge, as an extra question, you can use these P and N positions to describe this in a pretty nice way there as well. You can use the characterizations we just went over to prove this quite easily this way. So let's start with our P and N positions here. So I want to do this almost agnostic without really thinking about Alice and Bob, who's winning or stuff like that there, right? What are our P and N positions in this case? Well, the free P position is, well, when you remove the last token, you win. So that position is a 0, right? If you can get to 0, then you have won the game. That's a previous person then. I take the last thing, game's over. The previous person to move, that's me, I won. Well, remember our rule, right? From the previous slide. Whenever you can go to a P position, that's good, right? When is it going to be an N position? The next player, the first player to move wins. Well, pretty obviously from here, they then win at 1 and 4. Because 1 and 4 go to this 0 right there. You can take the last tokens and win, and then you're done in that case here. Now, here's where the forcing of stuff comes into play a little bit. And this is where this is helpful in terms of these P and N positions. And actually, this is going to get a little too cluttered if I keep all the arrows here. But, right, 1 and 4 come from the 0. Now, what about 2? If there are 2 tokens left, you're forced to go to 1. Remember, the P, let me put the star by this quick. This is where we want to be. This is the good place. If you can't move to that place, right, then the previous person to move is winning. So if it's at 2, you're forced to go to 1, and then the next person takes the token and wins there. So that's where we can start building these things up. And our numbers jump a little bit, but remember, you want to end up in these P positions. If you're the next person up and you can move to a P position, that's good. So we can label here then 3 and 6 because those both go to 2. So in a sense, these N positions we're filling in. As soon as we have a P position, any place that you can get to that from becomes an N position. And then when you're forced to go into a N position, you're a P position. So what does that mean? Well, that would put 5 here. From 5, you either take 1 token, that puts us to 4, they can win, or you take 4, and that puts you to 1, they can win. That's kind of a previous position win. That's a position then that you want to try to get to. So 6 also could lead to 5. So from 6, you could take 1 token to get to 5. Or we also have 9 leads to there, right? Anytime we have the P position, we can fill in those N positions here. And now we can start building up this way. What about 7? Well, from 7, you have to go to either 6 or, right, 3. Notice though, those are both in the bottom row. They're both in the N row, so 7 shows up here. As soon as we have 7 there, 8 and 11 go in the next column. And then we say, well, 8 and 9 are there. What about 10? 10 goes up here, and hopefully you're starting to see a pattern in this case, right? Once we fill in 10, 11 shows up, 14 shows up, and we could continue in this manner. The pattern that we have is, and this is where I'll let you go and try to prove this, right? The P positions are going to be 0 or 2 mod 5. So if you want to say this without mod 5, all of the things that have remainder 0 or 2 when you divide by 5. So 5, 10, 15, 20, 2, 7, 12, 17, things like that. And the N positions are the other. So 1, 3, or 4 mod 5. And right, verbally, really quickly, you can start doing what we were talking about earlier, right? From a 0 or 2 there, right? If we're 0 mod 5 and we take 1 or 4 tokens, we end up with a remainder of 1 or 4. If we're at 2 and we take 1 or 4 tokens, we end up at 1 or 3 remainder when we divide by 5. So from the P position, you're forced to go to the N position and vice versa. Now, remember, right, we also characterize this as wins for the specific players in this case as well. So if it's a P position, right, those are the positions that Bob will win. So Bob wins those scenarios here, right? So if we start thinking about those, these are 0 or 2 mod 5, right? I'll do this counting fairly quick. So we're going up to 2024. So our highest multiple of 5 is 2020. Remember, 0 isn't an actual starting position. So Bob can win if it starts at 5, 10, up to 2020 tokens. So this is 404 outcomes. For the 2, we have 1 extra because of 2, right? We have 2, 7, up to 2022. So there are 405 ways that Bob wins in the 2 mod 5 case. So there are 809 total in this scenario. But really, these P and N positions can be used in a lot of different scenarios, a lot of these types of games. So I encourage people to start getting comfortable with them and seeing what other types of problems you can solve with them as well. We do have a whole day or a whole half day at our camps going over some of these different games where these P and N positions come up as well. That will be good, however, for today. So stay tuned for some new ideas and problems next week. If you liked this video, give us a like, subscribe to the channel, check out another video. Otherwise, I hope to see you again next week for some more problems and math problem solving. Goodbye.